right, if you're in an operating systems lab, you've probably been introduced to the Linux terminal. And let's be honest, it can look a little scary at first. But I promise you, by the end of this, you're not going to see it as a hurdle. You're going to see it as the single most powerful tool you have for all your coursework.
So you open it up for the first time, and this is what you get: a black screen, a blinking cursor. It feels kind of empty, doesn't it? But here's the thing. That's not emptiness, that's potential. This is the most direct way you can talk to your computer. There are no icons or menus in the way. It's just you giving commands straight to the machine. So let's get into it.
So here's our game plan. We're going to start with what the terminal even is. Then we'll learn a few basic words, your very first commands. After that, we'll start moving around and organizing things. And then the grand finale, we're going to take plain old code and turn it into a real program. And finally, we'll look at a way to make that whole process a lot easier with something called makefiles.
Okay, first things first. Before we can start using this thing, we need to understand what it actually is we're looking at.
Here's a little secret. You're not actually talking directly to the Linux operating system. You're talking to a program called the shell. Just think of the shell as your personal translator. You type something, the shell figures out what you mean, and then it goes and tells the OS what to do. The OS does the work, gives the result back to the shell, and the shell shows it to you. Simple as that.
Now, for anybody coming over from the Windows world, you need to pay close attention to this slide. This is probably the #1 thing that trips people up. In Linux, file names are case sensitive. That means myfile.c with a capital M and myfile.c with a lowercase m are two totally different files. Seriously, remembering that one little fact is going to save you so much grief in your labs, trust me. All right, we know what the shell is, we know where we are. Now it's time to actually learn the language. These first few commands are like the basic vocabulary that you're going to use all the time. And luckily, the grammar is super simple. Every command is basically a little sentence. You have the command name itself, that's your verb, the action you want to do. Then you can have options or flags. Those are like adverbs that change how you do the action. And finally, you have parameters or arguments. That's the noun, the thing you're doing the action to. The very first command you should learn, hands down, is pwd. It stands for Print Working Directory. Anytime you feel lost and have no idea where you are in the file system, just type pwd, hit enter, and it'll show you. It is literally the "you are here" map for the command line. And these 4 commands, these are your lifesavers. If you don't know how a command works, man will pull up its manual page. It's like a built-in search engine. History is amazing because it shows you all the commands you've typed recently. Clear just tidies up your screen when it gets too cluttered. And, well, exit, that's how you say goodbye. Okay, we've learned a few keywords. Now it's time to actually start moving around our digital workspace and, start organizing things for our projects. Really, you only need 2 main commands to get around. ls is for looking around to see what files and folders are here. And cd is for change directory, which is how you move into one of those folders. And definitely check out these pro tips. cd ... to go up 1 level. You're going to be typing that one in your sleep. So we can move around, but how do we actually create stuff? Well, mkdir makes a new directory or folder, and touch creates a blank file, which is perfect for when you're about to start writing code. For getting rid of things, you've got rmdir for empty folders and rm for files. And I need you to listen to me very carefully on this last one. rm is permanent. There's no recycle bin, there's no undo. When it's gone, it is gone. So, be careful with that one. Now let's talk about cp versus mv. Copy, CP, is pretty straightforward. It just makes a duplicate of a file. But MV is kind of a 2-for-1 deal. You can use it to move a file from one place to another, or you can use it to rename a file. You're basically just moving the file from an old name to a new name right in the same spot. It's super handy. All right, this is it. This is the moment where everything we've just talked about, all those little commands, comes together for the big payoff. We're about to take a simple text file and turn it into a real working program, all from right here in the terminal. So first step, we need to write some code. And you don't need a big fancy application. You can use a simple text editor called Nano that lives right inside your terminal. We just type our code in, save it, and that's it. We've got our source code file. Now, turning that code into a program sounds complicated, but it's really just 3 simple steps. We already did step 1. We wrote the code. Next, we have to compile it, which is just a fancy word for translating our C code into machine code that the computer actually understands. And then, finally, we run it. For the translation step, we use a command called gcc.
We tell it what file to compile, and then, and this is a really good habit to get into, we use the -o flag to give our final program a name. If you don't, Linux just calls it a.out, and that gets really confusing when you have more than one project. So always use -o.
And here we go, the final step. To run the program we just made, we type // and then its name. That little // just tells the shell, hey, look for the program right here in this folder. You hit enter and there it is. Hello world. We just made a computer do something. That is awesome.
So that was great for one file. But what about a real project? Something with 10 files, 20 files. Typing that compile command over and over again would be a total pain. And that's where we level up our skills with a tool called Make.
Yeah, in a real lab assignment, your code is probably going to be split up across a bunch of different files that all depend on each other. And if you change one file, you might have to recompile 3 other ones. Trying to keep track of all that in your head, it's a recipe for disaster.
So the solution is this amazing little thing called a makefile. It's literally just a text file that acts as a recipe for building your program. You write down all the ingredients, your source files, and the instructions for how to put them all together.
Each step in the recipe has 3 parts. There's a target, the thing you want to make. There are dependencies, the ingredients it needs. And there's a command, the instruction for what to do. But here's the absolute best part. Make is smart. It's lazy in a good way. It looks at your files, and if nothing has changed since the last time you compiled, it doesn't do anything. It only rebuilds the stuff that's absolutely necessary, which saves a ton of time.
So just take a second and think about what we just did. We started with that intimidating blank screen. And now you know how to navigate, manage files, write code, and compile and run a program, all from the command line. This isn't just some random exercise for your lab. This is the absolute foundation of how all software gets made.
So don't look at that terminal as a chore anymore. It's not an empty screen. It's a blank canvas. It's the most powerful and direct creative tool you have on your computer. So the only question is, what are you going to create first?